Okay, and we're back, guys. Hey, how you doing? Thank you for joining in for another video, the third video of our software algorithm YouTube club. So let's talk about this problem that our team did today. We're tackling three problems, and we're going to cover two of them that we did. The first one we're going to cover is the growth of a population. And also, disclaimer, please like and subscribe if you like anything here because it helps us just to grow and to get this knowledge out here. So, in a small town, the population is P0 equals to 1,000 at the beginning of a year. The population regularly increases by 2% per year, and moreover, 50 new inhabitants per year come to live in the town. How many years does the town need to see its population greater or equal to P equal to 1,200 inhabitants? Okay, and we're just going to go over an example over here. At the end of the first year, there will be 1,000, and then we're going to do, so the 1,000 equals the P0 equals 1,000. This one right here is together. This one tricked me up kind of bad because I was doing pluses in the beginning when I was doing like the algo. When it's the percentage of the 1,000, it's the percentage of the 1,000 with the 2% plus the other 50 that comes in every year. Okay, so we're testing this to see if this is going to be over 1,200, but we see that it's only 1,070, and we need to be able to put over 1,200. So you can use a counter. You could probably use a for loop or a while loop. I usually use for loop. So for this particular problem, I decided to change it up for myself and to use a while loop. So when it goes to the other iteration, it's going to test the same case. Hey, with this same type of calculations, does the inhabitants now equal over 1,200? No? Okay, so we're going to do it again until we have a test case that passes saying that our inhabitants is now greater than 1,200, and we'll return that counter, which is 3. It would need 3 entire years. So I'm going to show the way I decide to go about this problem. And I'll show another example from a cool guy that just joined the club named Tom. So with mine, I decided to have the percent because it says here at the bottom, it says don't forget to convert the percent parameter as a percentage in the body of your function. If the parameter percent is 2, you have to convert it to 0.02. And sorry about that mumbo jumbo of the first parameter. I don't know what happened there with my mind. Okay, so over here in line 2, I decided to save the percent in a variable called per, short for percent. I decided to create a counter variable as well as inhabitants for the P0. And then I decided to do a while loop. As I said, the while is saying, hey, for inhabitants, you could also probably do it in edge case, which will probably work as well. If the inhabitants is already greater than 0, so you could probably just return it's already greater 0. You don't even need to go through the counter. I didn't do that. I didn't do edge case. So I did while inhabitants is less than P. I'll put up my curly brackets to put my conditional in. I said to set inhabitants to inhabitants plus the percent of the inhabitants. So this is for this one, it's going to be taking at the bottom over here on the terminal that it has on line 3, it's going to be taking 1,500 times 0.05 because that's converted into percent. That's the number that's going to be here, plus the people that residually come in every year, which for this particular problem, the argument is given 100. So you're going to have 1,500 plus the percentage of inhabitants plus 100, and it's going to also increase our counter. Once it passes this line, it's going to increase our counter by 1, saying that we have 1 year so far. That's what it's representing in this problem. Then it's going to go again to say, hey, now with our updated count, with our updated inhabitants, because now we're changing what an inhabitant is equal to. Now, is this less than or greater than our population that we need to surpass? And then if it's less than, it's going to go through the whole while loop again until the inhabitants is greater. Once this conditional is met, it's going to return the counter, which is for this one, I will have to run the test, and then you might see it on the side. Let's see. We see that it passed, but it might say 3, or it might say 4, and that's representing how many times the while loop was gone through until we had the inhabitants greater than p. All right, and that was a fun one. So I'm going to show another work with this, so we can check out this one right here. Okay, so the way Tom decided to go about it, he decided to say, while he set his same parameters, he did per equal to percent divided by 100. He had a counter, and he had a current populations equal to p0. He's saying while true, okay, he's putting in, this is conditional, if current population is greater or equal to p, break. So if current population already off the gate is greater than p, just break, and we're going to stop there. Or he's going to do come down within the conditional. We're going to hit line I, saying that current population plus the percentage of the current population plus the residuals that come in every year is going to be set to current population, which would go to line 4, which would now set another current population, increasing it, and we're also going to increase on line 10 the counter that will increase line 3 to 1. And once that isn't true anymore, we are going to return, when it's not true, then we're going to return the count. So for both of us, just make sure, I would say, to take your time. It could be nerve-wracking at times, but just take your time, go slow, understand what the problem is asking you. If you need to write it down before you even type anything, type it down and understand what the problem is asking you, because for both of us, we got hung up on adding inhabitants together when that should have been a percentage if we would have took some more time. Another thing that I did was I put also at one point a plus equal, so I did another addition that wasn't even supposed to be there. So the more you play with it, try to understand and try to learn from your mistakes. And also, it's also really good to talk about your code out loud. So I noticed when I might be asking one of my partners for like a little hint, I would be explaining the problem to them while they're working on the problem themselves, of where I'm getting stuck. And then once I'm saying it out loud, I'm seeing where my error is at. So essentially, I really didn't need to ask the question. I just needed to say it out loud, and then I was able to see it a little bit better for me to catch certain mistakes. So I hope that helps you guys, And if you have another way that you could solve this problem, please share below in the comment section. Like, I would love to see it, as well as everybody else. So for our next one, this one is a little bit quicker, and it's also like a good one to look at. So we decided to do this problem. It was write function remove exclamation marks, which removes all the exclamation marks from a given string. So my initial thoughts was, hey, this is going to be really fast. I could probably use something really cool with .include or .char at. Those were my two thoughts. Did I know how to put it into fruition even though I had the thoughts? No. So for me being stumped on how to use those two, I decided to go with a way that I knew for sure was going to work, even though I know that there's a shorter way to actually do this. So I decided to do this code that's right here. We have in the beginning, I have the whole string, and then I'm going to talk about some really cool refactoring methods we could do with this. But I have in the beginning, I have a string which is S right here. I decided to split the string on every single element that's within the string. So now every single let me break this up for you. You can see this element is broken up individually. So console.log array. Let's see if you can see it. Okay, it's telling me that I passed. Thank you guys. Thank you for letting me know that I passed. Okay, so initially this was just saying hello world with an exclamation point. So let's go back to the first one so you can see it. It shows this. It says hello world, and our task is to remove that exclamation point. So I decided to break it up, as you say, split into to have every single element, and then what I wanted to do was set it into everything into like a new array, which is the result. And I went to the for loop. I decided to use a for loop for this one, and then this for loop is incrementing by 1, and he knows by 1 by the I++ at all the way at the end. Within the conditional, I said that if that index of array does not equal to an exclamation point, please push that index into the result array right here. Okay, and then at the end, once everything is pushed, because it is going to be pushed just like this, but that's not how we write regular letters, and that's not how they want it to look. They want it to look like on the left hand side where it says hello world, just normal, a normal string. So at the end on line 12, I said to return result.join at the empty space. Okay, and as we see, that worked perfectly. It said that we passed. But something cool that I learned, and that I would love to refactor with you guys, is in the future, if you're working with strings, you don't even need to split it. The for loop is able to go through every single element by itself. So this is essentially not needed on lines 3 and line 7. So let's play with it real quick. That's the reason why we're here. Okay, and it's true. Thank you, Sierra, and also thank you, Jack, because as learning goes, Jack taught Sierra this, and Sierra taught me this cool trick, and I'm putting this on YouTube so everybody can learn. So, and this is just how learning works. So I'll repeat it one more time, if we missed it. If you have a string, you're able to traverse through every single element of that string without having to split it. So, and that's a cool time saver, and that also helps with a little bit of your time complexity. Just a little bit, probably not too much, but if you're not splitting it, that removes like a whole nother method that you're not actually using it, so you have a better time complexity there. So that's really cool. And let's check out one other way to solve it. So let's bring it up. So this is Sierra's solution to solve it. Let's take a look. She did it two ways. So her first way, which is really smooth, a one-liner. You can see in line 2, it says she splits it to break it up into individual indexes, and then she uses the filter method, which she's saying right here, saying, hey, in this method, if you do not see, if it doesn't equal an exclamation point, return this into a new array. Okay, smooth, right? And then she added the dot join method on top of there, so you have a smooth one-liner, just in case you guys want to use that. But the only problem is with this one-liner, the time complexity was a little bit high, so she wasn't satisfied. She's an overachiever, and that's how we should be, you know? Like, if you see one thing that works, why not play with it to see if we can make it better? And that's what she did. So she decided to say, hey, let me actually break it down into another method that doesn't use too many splits and filters, because a split, a filter, and a join, this also increases your time complexity of how long it's going to take to run your algorithm. And her using it this way is using less resources to make her algorithm faster, and that's what she was going for, a more optimal time. So with this way, you're seeing that she set her results to an empty string, and then she used the for of, which is another way that you could do it, for char of s. If char doesn't, or character I like to say, doesn't equal the exclamation point, push, it's not push, but concatenate that element to the result variable that's defined there, and then return the result. Nice and smooth. So these are two different ways that you could have solved the problem that we're looking at now, or the first problem that we looked at in the beginning. And I hope that you guys like this. Again, if you find some value, please share this to your friends, and thank you for watching the video, and I'll see you next time.